Okay, so hi, thank you all for coming. Unexpected, of course. My name is Jachym, and I'm contributing to open source software, or I used to contribute to open source software and visited lots of FOSS4Gs, but now I work at MapTiler. MapTiler is the company. We do maps for developers. And mostly what we are doing map tiles. And we tile all sorts of data, raster data, as well as vector data, and also all sorts of input data as well. So this talk should be at the beginning about the topic whether you should tile or not to tile, or what to tile. So let me give you an example. This is a standard OGC WMS request, right? With all the versioning and bounding boxes and target coordinate reference system. And when you're running it like this, and wait, and eventually you should get some result if everything is configured okay. And the result should look like this, for example, a aerial image. On my computer, my laptop, it took 21 seconds to get generated. I consider 21 seconds too much. Imagine you would be loading an application and every tile would basically, or it would take maybe half a minute, maybe 1 minute to get loaded, then you get stuck with the connection to the server. The testing data, I was just using just normal aerial images, right? One gigabyte in total, 4 files, using a national Swiss coordinate reference system. No big optimization inside. This is how I downloaded the data from SwissTopo. Many thanks for sample data. So it shouldn't take so long. Why? Because all you need to do, or the server needs to do, is to read all the data, all the input data, perform the resampling, changing the format, but mainly the most costly part is the transformation from one system to the other. And this has to be done somehow on the fly. While tiling, you do this all things ahead. And then you reduce the time needed to see your data from 21 seconds, in this case, under 1 second, of course. There's a great blog post article about how this tiling works, available on our server. If you just Google for tiles, a la Google, you will get there. And most of you apparently know the system, right? That the world is split into usually squares, and with every zoom level, every square has its own coordinate, depending which tiling system you are using. You are starting either on the top left or on the bottom left, but this is a small thing. And with every zoom, you have 4 times as much tiles as in the previous one. Eventually, we will cover the whole world with very small ones. So the process of tiling is that you have some input data, in my case 4 tiles, and so on, and you convert them, transform them into output data set, which has, instead of 4, it has, in this case, 1,500 images. And the coordinate reference system is the target one, in my case Mercator, and the resulting output is about 100 mega. So there were 1 giga in the input, and there is 100 mega in the output, which is already something really prepared for serving tiles. And you can tile all sorts of data, vector data and raster data. There can be satellite or aerial images, there can be terrain data, or for example, weather data as well. Or of course, 3D vector/mesh data, whatever. So I claim everything can be tiled. But how to tile? You need to pick a right tool for it. And there is all sorts of tools, and this is actually what this talk is going to be about. But first, let's assume some choices. The first choice, how will the output format look like? Basically, you have 2 options, most common options. You tile into so-called raw files, you store them directly to the hard drive, or use some kind of SQL3-based database. It can be either MapTiles or OGC Geo package. But they are the same. MapTiles has was developed by MapMox, and it supports only one coordinate reference system, but you can store raster and vector data there as well. And it supports only tiles, while OGC GeoPackage is more universal. It supports virtually all projections, raster and vectors as well, but also you can have tiles as well as source data like vectors or rasters in one file, in one database. But both of them are based on SQLite 3, so you can pick whatever you want and they will be probably similarly fast and similarly big. And then you can also, of course, store files directly on your hard drive. It has lots of disadvantages. I suggest you don't do that. But there is one big advantage. It is pretty much easy to be understood, and you don't need any server for serving the data. But it's very hard for manipulation. It's very demanding on the hard drive. You can't index it, and so on. Next choice you will have to make is how big the tiles should be, because originally we started with 256 big tiles. This is how we started some times back, right? But nowadays, more and more applications are using twice as bigger tiles, 512 pixels. The difference is that you will cover with less tiles, bigger screen. And with growing screen, this is essential because there is less requests coming, so more data coming in per request, so to say, between the server and the client. So nowadays, more and more applications are switching from 256 tiles to 512 pixels. So I suggest you do that too. Next choice, file format. How actually in this SQLite 3 database are the files stored? What is the format? For vectors, you have two choices. For rasters, you have more. But basically, for rasters, you need something which is supported by the web already, with the web browser, because this is something which will be displayed at the end. You have PNGs, where you have transparency, but for some data, this is relatively big. You have JPEG, which is relatively small for some data, but there is no transparency. You maybe recall there was some combination you used on the edges, right? On the edges there was PNG, inside it was JPEG for satellite or other images. That is a possibility, but I suggest you switch to WebP format. WebP is relatively new, but you have both. You have great compression and you have transparency there as well, and the output looks simply great. Next choice, tiling schema. I was already referring to Web Mercator or Google Mercator projection, if you please, where the whole world is somehow covered and somehow split. This is a well-known go-to choice with lots of disadvantages, some advantages. We all understand that Greenland isn't as big as Africa, for example, and so on, but we can live with that. Why not? But there are others, and you may or may not need them for your application, like WGS 84 tiling schema, for example. And there are local tiling systems, like in Czech Republic we have JPEG. In France there is another. Altogether I have seen, well, around 140 tiling schemas. You can split them. They are local or global, using quadri or decadic row. 2D or 3D, whatever. So choose wisely, and but I suggest, if you really don't have a good reason, stick to Mercator, because it is then supported by all the libraries you are probably going to use to display them. So those are my decisions. I want MB tiles or GeoPackage as output, WebP for raster data, 512 pixels big tiles, using Mercator tiling schema. This is my target. So now I'm going to speak only about raster data. I'm not going into the vector data topic. Let me remind you that my testing data set was 1 gigabyte big, 4 tiles together, using Swiss local projection. The map tiling tools we can use, what I found and tested, I could split them into, let's say, 3 groups. There are those who are GDAL based or Goodle based. Then there are some seeders which are part of distribution of mapping servers. Then they are some integrated into QGIS, and at the end of the day, they are of course GDAL based, but you have a graphical user interface to it. And then there is the MapTiler Engine. Let me start with GDAL tools. If you Google for it, there are some Python scripts which are mostly Python 2 based, so obsolete, and you basically can't use them on nowadays systems. But then there is GDAL 2 tiles, which is up to date, works with Python 3, and it is part of GDAL distribution. So if you install GDAL, you have it already in your computer. If you run it, if you look at help and manual page, it supports 512 tiles pixels. It supports WebP output. This is great. It supports both the XYZ or TMS tiling schema. So either the image, the tiling schema starts here or here, which is also nice. It supports multi-thread, so you are not tiling only one core. So it should be faster. Disadvantage, it doesn't support MBTiles or GeoPackage output. You just get the raw files, and it doesn't support multiple file inputs, because if you are going to tile, well, big piles of data, then you have made, I don't know, hundreds or thousands even input geotiffs, and you need to deal with something. So as a first step, I have done GDAL build VRT, so created a virtual raster file from the input TIFFs, and this allowed me to run GDAL2tiles command, and as in the output, I got all the files rendered. And it took on my computer about 3 minutes, and the output was about 100 megabytes big. I'm satisfied. I needed to convert it into SQLite 3, so MBTiles or GeoPackage, in order to get them visualized somehow, but I got the job done. So you have to count some extra time to it. There is another way how to do that. You can use directly GDAL translate plus GDAL add-ons, C-based commands. With GDAL translate, you translate the VRT to MBTiles. That works relatively well, perfectly, but there is no, you don't have the whole pyramid. You have only the finest resolution. For some reason, this min zoom and max zoom didn't work. I'm not saying that I did everything correctly. I tried, and this is also part of this talk, that you see how you can fail, basically. And then the next command is GDAL add-on, where it should do the pyramid. But I never managed to get it completely through. It was relatively slower, and the output was relatively big because GDAL directly lacks support for WebP. But it's a heavy-duty tool. It is always in your system, and if you just somehow it works for your use case, use it totally. So those would be the GDAL-based tools. Then I'm switching already to server-based tools for, let's say, first one is MapTiler on my list. For MapTiler, you need 2 configuration files. First one, there is so-called map file, where you configure the input and data sources and outputs format and cartography. In raster data case, I don't do any cartography, but this is how the software works. And then you configure. Then you need a so-called map cache configuration file, which is a XML-based structure, where you configure that the data should go from MapServer, and you define the tiling schema, output format, etc. This is the sample of the map file, how it looks. So, well, it starts here and continues here, and here you can see the input layer described, and yeah, that it's, for example, supporting, where do I have it? I saw it here, WMS requests in Mercator schema and so on. This is only a part of it. And then I have the map cache configuration file, where I defined the proper tiling schema using 512 pixels big files, for example, and output was MBTiles. MBTiles is supported. Then you run a command line tool called mapcacheseed with a configuration file, and it took 5 minutes in total. But when I tested the output, there are more output options, not only MBTiles, right? But when I tested MBTiles, the metadata table was missing, which is essential for MBTiles. I have to regenerate them, and at the end of the day, it was working. But yeah, I had to do some tweaks, and the output was relatively big, and it took relatively long even for me, well, I'm no longer MapTiler experience, right? Or MapTiler. Thank you, MapServer expert. But it took me quite some time to get it configured, and the output was big because it doesn't support WebP. And there is obviously GeoServer, and I'm not a GeoServer expert as well. However, GeoServer is known for its graphical user interface, and it is Java-based. It's a great tool. I can recommend it for lots of use cases, and there are 141 tiling schemas directly supported within the tool, which is great. But if you want to use it, for example, with more raster data files, you totally need to install GDAL extension. The WebP output is missing, and MapTiles cache or SQLite 3 based cache is missing at the moment. This is how it looks with the grid sets. I was really, well, you see only a table, right? It's not focused, but you had the idea. It supports lots of tiling schema. And then you configure so-called blob store, which points somewhere in the hard drive. And when you run it, then you can see that it uses some number of cores, in my case 4. And at the end, when it is done, I got the output into files. But it doesn't, as I was saying, support the WebP, and it took about 15 minutes because I was using only 2 cores because more were unstable in my system for some reason. And it was relatively big output, surprisingly. When I converted it to MapTiles using my custom tool, then I got to reasonable size, so there must be some kind of trick I'm not aware of. Something isn't working well, but this is what you got. Output about 2 gigabytes, big, somewhere stored in your file system. Yeah. So I'm not satisfied again. QGIS integrated tools. One of them is directly being part of QGIS. It's called Generate XYZ tiles, but it lacks support of WebP, only small tiles. Use it only 1 core, so it takes relatively long to get done, 6 minutes. And the output is relatively big, probably due to format, but it gets the job done, I can say, right? At the end of the day, they were the tiles as expected, well, in different format and so on, but it was working, and it was stably working. QTiles is a plugin you can install. I have tested it. It claims to support basically almost everything I need, except for WebP here, and it seems to be running on single core as well, which is unfortunate if you want to process big piles of raster data. And the viewer didn't really work. After some tweaks again, it was working quite well, but this talk is about producing the final database, not about leaflet viewer or some simple viewer. It took relatively long to get it. The output was relatively big compared to for example, GDAL 2 tiles. And when I tried this was working when I was trying raw files output on the hard drive. When I tried MapTiles output, it like never finished. It just stopped hanging there, and yeah, didn't get the result. So I consider it like unstable for my use case. Okay, so now let me introduce you MapTiler Engine, the tiling tool. MapTiler Engine is the tool used for tiling raster as well as vector data. And it works in a way that you simply drag and drop your files into the system, into the desktop application. Then you can see preview the input. Here we have all the statistics of the input files. Then if you want to tile it, apparently you want it, you pick one of the tiling schema. You pick the output format, which can be GeoPackage or even Google KML or MapTiles, or even raw files if you prefer. I don't suggest that. And you can pick also a variety of output choices, like whether there should be transparency, which compression output format you should use, whether WebP, JPEGs or whatever, and zoom was. When you just let it run, you can see that it was running on all 8 CPUs in my computer. And at the end of the day, you will get some preview, which you can't see here, but there is a preview of the output. And when it is done, it is integrated with all my, not with all my, but with all available cloud services. Well, apparently with MapTiler Cloud, well, the data can be uploaded directly, but also with other cloud services on cloud providers. There are also more options for rasters and vector data, for example, Cutline. watermark. Cut line is that you have a border of the area you are interested in, because in northern part of Italy, for example, there are only white spaces in Alps, and you really want to cut them out, so you apply a vector cut line, and so on. Let me remind you of my input data set again. When I run it, this is what I want to see, which you can't see, but this is output of htop, and all cores were used. And it took in total 27 seconds to get done on my laptop, and the output file was, well, 100 and something megabytes big. So this is what I want to see. This is the table. If you want to make a picture of something, this is my result. That would be probably it. MapTiler Engine proved to be best tool for tiling of, in this use case, raster data. It supports, and I hope I justified reasonably why I want WebP and why I need support for MapTiles or GeoPackage or whatever. And you can see that the fastest one, GDAL2 tiles, was 6 times slower. And only thing I got was files on the hard drive. So if I wanted to move them into MapTiles, you need to add some more processing power. Yeah. I'm already running out of time. Sorry for missing the lunch. Very shortly, it has also command line. MapTiler Engine has a command line interface, so you can automate things on the server, and you can input as many files you can, basically thousands of files I've processed with that. As an example, we used it for our satellite dataset, global satellite dataset, for our RGB terrain/hillshade datasets as well. And we used it, for example, for aerial images of New Zealand. They were 1,000, you can't see it, 1,000 input files. Altogether, it was around 4 terabytes of input data. And we have to split it into 3 regions because of the data manipulation, because these 3 regions, each of them had about 200, almost 400 gigabytes. So I have 3 files, MapTiles, which were around 200 till 400 gigabytes big. And this is what I had to upload to MapTiler Cloud platform. Our colleagues were pretty happy about that, but finally we managed. It took about a week of processing time on Microsoft Azure virtual machines, but we get the job done. You can see the result on our maptiler.com/maps. If you zoom in and switch to satellite, you will see the output. This is well, overview of the 3 regions I had to split the islands into for further data manipulation. And yeah, if you want to process even more data, I mean, this is an example about real use case scenario, processing big piles of data, right? But if you want to do something even bigger and you have even bigger budget, then we are reconstructing and redeveloping so-called MapTiler cluster, which enables you to run this engine tool on many computers, and you can burn endless money in AWS infrastructure. Is that all? No. Let's talk about more topics. We could touch the topic of vector, of course, while there is a RGB, for example, used, or how do we encode the terrain information to RGB tiles? What is the difference between GeoPackages and MapTiles, and so on. But let's stop here. There is more talks from MapTiler. I would love to invite you to talk from Petra Juriačiková this afternoon about how to style, advanced styling and cartography using vector tiles and style JSON file. Then there is Jonathan giving a talk about MapLibre extension, basically, MapTiler SDK. And JavaScript development, and Tomáš Pohanka will give a talk this Friday about open state-of-the-art of OpenMapTiles project. And now it's time for either lunch or questions. Thank you for coming.
Thanks, Jachym. There are any questions?
Everybody's hungry. Yeah.
Is the open source?
No. So, to make this clear, MapTiler Engine is not open source software. Therefore, I gave you the overview at the beginning of all the open source software I could find, and you could see the difference and make your choice.
That you show, so is something that you have in.
I'm sorry?
The Docker is available, but
Yes, Docker is available. Yes.
but it's not.
It works for free. You can tile the data, but you will probably see some watermark somewhere down in the corner. Test it, and so on. Then talk to ourselves. Yes, please.
You kept mentioning so I want to know what are some of the best practices when choosing which ones to use. Tagging schemas.
Tiling schemas. Yeah, we can touch the topic. I don't want you guys, if you want to go to lunch, maybe you could go, but tiling schemas is generally, MapTiler, Google Mercator is the go-to choice because it's global and every library is using it. I'm sorry?
In the use case, you used
When I do the local ones, well, for example, in Czech Republic, Cadastre, they insist to have it in a local coordinate system, right? So we had to invent basically where it starts and define the tiling schema. Even some people thought that we are going to tile it using the decadic scale, then the squares are not regularly changing the size, right? But it doesn't make any sense to do that, and so on. But some data providers insist, and we are all solving the same problem: how to distribute big data sets the most possible cheap way, so to say, to the client. So, yeah, I know that, for example, cesium tiles. They, in the previous version, you had to tile it in WGS 84 tiling schema, but nowadays the library supports Mercator as well. Yeah. If you give me a concrete example, let's talk about it and let's talk it through. Yeah. Any more?
I have a question. You talked about using multiple cores for better performance, but what do you think about using GPU in such a?
That's a good question. I have no opinion about it. I don't know. Well, I use the tools which are available, and this talk isn't about development, and I'm not a professional, graphic developer, right? I'm a GIS guy. I'm actually a forest engineer. So this is, I just pick the tools which are in place and try to test them. Sorry, can't give you that, but Jonathan totally could give you some answer.
At the moment, we don't have to do process on GPUs, but GPU are known to super well perform on grid data, such as what used to be like textures, but generally rasters in different formats. So we could totally foresee that in the next few years, we could use like WebP or WebCat or whatever texture mechanism to send large pieces of data, probably not covering the whole lot, but like clustered in smaller extents. And chunk them down and see on GPU. That seems probably reasonable. It's just that at the moment we're not doing that, but we could.
But the break isn't the performance of the computer. You can run this tool on 64 cores, but then you hit the limit of your hard drive for both input and outputs.
Thank you.
Yep. Great. Thank you.